Hey, what's going on? Welcome back and thanks for joining me in my own personal brownfield site here. Good God, it's getting crazy. So last time we chatted, I was working on that dog tracker project, and that's still what I'm doing here. If you don't know what that is, you can check my last video. We're using something called a LoRa chip, long range radio frequency chip. That's that there. And we are trying to use it to collect GPS signals from a remote and display that on a computer so that you know where your dog is. You know, if you need a little primer on LoRa, you can maybe check the last video I did. Probably better to go off to the internet and find somebody that really knows what they're talking about to explain it to you. But it's an interesting new emerging IoT technology, Internet of Things technology, and I'm having a great time with it. So when we left off, I'd really just done the proof of concept for that thing, and we needed to work on the antenna and making the little tracker module a little bit smaller, and maybe a few other things. As you'll remember, the range I was getting out of this LoRa module with the little stick antenna was about 500 meters, which is okay, but not great. So in thinking about that range problem, I had an idea, and it goes something like this. I just spent the last few hours wiring together this. Yeah, I know, a few hours. It's tedious work when you've got barely any eyesight. It's terrible. Look at these connections. They're insane. Okay, so I just spent the last few hours putting this together. It's just a LoRa node, and we're gonna hook this up to a tiny little solar panel so that it can remain anonymous. And I think this what's gonna happen here is we're gonna make this into a relay node. So it will sit somewhere inconspicuous and capture signals and then relay them to the top of my house. So this will be somewhere within the reach of the top of the house, but not in reach of, you know, things further on. So this will be, well, you get the idea. It's a fucking relay. I think it's gonna fit perfectly in there, seal it up, put a panel on it, and just tack it to something inconspicuous. And yeah, we'll make a whole network of these things. Now, don't ask me why I started with that instead of trying to increase the range of the whole system with the antenna, but that's what I did anyway. That's not to say I don't love that idea. I'll probably still use it. The next thing I needed to work on was decreasing the size of the transmitter, the thing that goes on the dog. And I ended up doing something I don't normally do, which was to go buy something kind of pre-made. But it turned out to be a good idea in the end. So I buy a couple of these PCBs that allow you to mount the Pro Mini here and the LoRa node there, and you know, it makes all the connections for you on the inside there. So I kind of like it, except the form factor is a little bit long for the dog tracker thing. Anyway, I am constructing one as we speak. So there's what I ended up with. It's not too bad. It's fairly compact. You can see that the circuit board there is sandwiched in between here. And so if we go below deck there, we've got the LoRa board and the Arduino Pro Mini attached to this circuit board, which is great. All the connections are made. And then onto the LiPo deck, where we see we've got a GPS unit. Now this one is smaller than the one I had before. It's a BN-180. It's actually pretty good. They use them for drones. They put them in drones, and I like it quite a bit better than that other one. It's a tiny bit more expensive, but yeah. Not worth not paying the extra money for. And plus it's so small, right? So that's pretty good. Oh, here's a 915 megahertz antenna. This is the antenna for this thing. I ended up buying these off of eBay too. You could probably make them. I'm not exactly sure. I think the spacing in between the wires is important and the number of loops. I actually don't know, but that's kind of why I just bought them. They're damn cheap. So I just bought a pack of those. So for these nodes. Anyway. What else we've got? Oh, 200 milliamp hour battery right there. And this is the charge controller, same as before. The other thing that's interesting about this is I had these old cell phone charging cords with these things on them. They're little magnetic ends. They're shit for cell phones because they keep falling out. But in this instance, it's actually pretty good. Oh, where's the other side of that? So you can see, like, that's the one end that goes in your cell phone, and then this is the other side of the USB cable. Just clicks in and, yeah, starts charging. Seems like it's a good idea, but it was constantly coming out. So, anyway. So that's that. Now, surprisingly, I found all of this could fit in this. a pill bottle. It was almost the perfect vessel for this thing. So I put a little port at the end for the charging thing and attached a little switch there. And see, that just pokes out there for charging. And then these two things connect for the switch, and everything gets tucked in there. Little piece of foam in the end just to give it some support. And I fucking lost the cap. Fuck! What the hell? There we go. And that's it. It's a tiny little package. It actually works pretty good. And then to attach it to the dog collar, I just cut this little piece of plastic out of, I don't know, it was like a fan housing or something like that. So you just clip it in on, there's loops on the collar on either side, and it just clips into that, and then it doesn't come off. So it works pretty good. What I ended up spending most of my time on was the antenna for the gateway. And if you remember before, we just had a piece of wire. It's a stick antenna. It's nothing. It's 1/4 of the wavelength of the frequency, which is 915 megahertz. So this ends up being like 78 millimeters or something. Don't quote me on that. Whatever that is. And it's, you know, they gave us our 500 meters of range, but it seemed like there should be a better antenna out there for this. So what this ended up involving is going up and down a ladder a lot. And it's kind of a wonder I'm not in the hospital right now, considering. So we're going to do some antenna testing today. This is just a dipole antenna. So normally I would just have the one, but we've attached a ground plane to it, I guess. That's what you would call it. To the bottom, so that's called the dipole. The dipole antenna was quite a bit better than the stick. It increased the range from about 500 meters to 700 meters, but the most impressive thing about it was that it was able to capture more signals in more places. Antenna number 2 is a quarter wave ground plane antenna, and you obviously can't mount this directly onto the LoRa board, so that's where that external connector comes in. Alright, there's the 1/4 wave ground plane antenna. We'll give that a go. Well, things were going fairly well, and then I abruptly lost signal. I wonder if that has anything to do with it. I'll have to fix that. Fuck! Cable ties. Man's best friend. That should be a lesson for you. Don't be a lazy bastard like me, eh? So let's see how we made out with the quarter wave ground plane antenna. Just for reference, here are the dipole results. And wait for it. And here I thought it was shaped like a pyramid just to look cool. Turns out the Aztecs knew what the fuck they were doing, eh? So we've easily doubled the range to about 1.5 kilometers in spots, which is just fantastic for this dog tracker. Even with these fabulous results, the quarter wave ground plane was not our only hope. Yes?
There is another.
After those results with a quarter wave ground plane antenna, I was super pumped to try and make one of these. This is called a CoLinear antenna, and word on the street is it might even be better. Now here's something fun I didn't know before. If you take a copper wire and you stretch it, it not only gets longer, but it gets stiffer. And stiffer is always better. So I'm going to try to do that with this. Now, I learned this from Andreas Bees, I think his name is. You know, the guy with the Swiss accent. He hooked this up to a motorcycle and pulled it that way. I'm not going to be doing that, mostly because I don't have a motorcycle. So what I'm doing is I'm just going to twist this around this lovely brass pipe here. There, okay. And we're just going to use the power of leverage to hopefully stretch this out. We'll see how it goes. Okay, I can feel it stretching, and I don't think it's just unwinding here. Oh yeah, look at that, eh? That's awesome. Yeah, oh yeah. Okay, let's see what we got going on here now. So yeah, that works pretty nice. All right, so the outside, the OD of this little loop, you're gonna have to make 3 of them. The OD of this loop is 13 millimeters. Now before we get too deep into this build, I think I'd like to consult the future for a second. Hang on. Yep, I think that's about enough. So far, the tests with this CoLinear antenna are just horrible. Like worse than just a little stick for an antenna. So I don't know why the hell that is. I don't really, yeah, I don't know. I'm gonna just tweak it a little bit. The only thing I can think is I checked all the dimensions between the loops, they're fine. Except for this one, the first one, because you know, you have that little nub there. And I think perhaps it's, you know, you're supposed to measure from the base here to the first loop. And so maybe I'll just tighten that up again and give it a try. I don't really hold up much hope that this is going to work, but we got to do something to just test it out. Man, I had high hopes for this CoLinear antenna, but you know what? It's a piece of shit. Oh, you know what I'll do? I'll circumcise this thing and we'll test it out that way, because that just turns it right into this. Now you're going to feel a little pinch. So nipping the top off that CoLinear antenna resulted in fabulous results. I got a maximum of about 2 kilometers, which is better than the previous one of these that I made. So this definitely seems to be the way to go. I wouldn't bother with any of the other shit. Make yourself one of these straight away. If you want to make one of these quarter wave ground plane antennas for your very self, I suggest you get one of these. This is a SMA connector. And it's got a little nub at the end there that you can attach the top part of the antenna to, just solder it on. And then you just get some household copper wire and strip it down and solder it on like so. It's pretty simple. So just make a little bend in your copper, and actually I would suggest you make these longer than you make these radials longer than you need, and then chop them down at the end after you've, you know, measured the proper distance. Now, there's a calculator for this online so that you can get all your measurements right depending on what your frequency is. I'll put a link to that below so you can get going on that. It's super simple actually, and these are pretty strong, so that's kind of nice. There are a few things on the software side that you can do to get a little more range for your change with this Lora module. The first thing you can do is set the transmit power to 20, which is the maximum. It defaults at 17. The cost of that is it's going to consume a little bit more power when it's transmitting, but if you're not concerned about that, that's one thing you can definitely do. The other two factors, well, this is what I found anyway, that make any sort of difference at all are the spreading factor and phone robots. Evil. Little known fact, Skynet was actually just a robocall center. So there you go. That's where it all starts. So where was I? Two things that I found that actually affect the range are these two settings. There may be more, but I couldn't figure them out. So the first one is the spreading factor, and the other one is the signal bandwidth. The spreading factor you want to get as high as possible, and the bandwidth you want to get as low as possible. And the way I did this is I kind of set spreading factor fairly high. I think maybe I started out with 12 but couldn't get any good results with that, so I dropped it down 1. The maximum is 12 to 11, and then I started lowering the bandwidth. I think it starts out at 125 megahertz, and there are these steps you can take down, so preset frequencies or whatever that you can lower stepwise until you get something that works for you. So what I found that is if this was too high, you would end up getting garbage, and if this was too low, you would also end up getting garbage. So I kind of tried to make them meet in the middle. So that's all I can say. I don't really understand what that's doing, but that seems to be what's happening here. So yeah, screw around with that. All right, today's the day we're going to launch the repeater unit. I think I found the perfect place to put this. It's right at the end of the range that I've got currently, and we'll see if this is going to work. So far it seems like it's going to, just from local tests here, but you know, until you get it out in the field, you'd never really know. Okay, do you see it there? It's actually, I'm not sure how much sun it's going to get. I'm a little concerned about that, but it's well enough hidden. I'm about to head out to test that relay, and I'm back at home now, and I was actually getting relay information from this. So what was happening was the transmitter here was hitting the relay was bouncing it back, which is just crazy. So that seems to be working, but just let's see what the range is like now. There's the relay there on that pole, and we'll just test out the range past it. That repeater is sitting somewhere around here, well, probably where that smudge is. And the distance from the gateway to that repeater is 1.2 kilometers. Now, the furthest distance I could get away from the repeater was actually another 1.2 kilometers for a total of 2.4 between us here. And that, to me, is pretty damn good. Now, it doesn't do a hell of a lot of good out here because, as you can see, there's next to nothing around this area. But it just gives you an idea that this repeater business is actually viable. It'll work. And you can throw as many as you want out there, and they'll just bounce signals between each other until eventually they hit your gateway. So yeah, you can extend the range of this like infinitely, maybe? I don't know. So yeah, I'm pretty happy with that. Now I just got to find a better place for that repeater. Higher up you can get, the better. I mean, the problem is these are pretty close to ground level when you're doing it on somebody else's property. So yeah. Anyway, we'll figure something out. I think I'm going to wrap up this little sideshow right about here. I got a couple of observations, though, before we go. First of all, these little spring antennas, if you don't have to use them, don't. They're not that great. They're okay if you need to save space, but other than that, not so good. You're better off, if you can do it, you're better off to just use the stick antenna. You'll get better coverage, better range out of that than you will out of this thing. So I know there are other types of internal antennas. I don't have any, so obviously I can't test them, but maybe somebody else out there has some good results with those. But for this, only if you're saving space. Now, observation number 2 is this repeater unit does something kind of interesting, and that is if the transmitter and repeater are close to each other, there seems to be some sort of cancellation effect or something going on there, because you may only get one of them coming through, or you may get a little bit of garbage coming through, or it seems to depend on the timing. I don't know exactly what's going on there, but the way I solved this problem was originally the transmitter was transmitting every 5 seconds, and this would simply pick it up and spit it back out again. So what I did was I changed this to repeat every 8 seconds, and then I put a 3-second delay on this. So what I think that does is it gives the air time to clear. It may not actually be too much of an issue out in the field, but you know, just be aware that that's something that could happen. So anyway, that's about it for me. Thanks for watching. I hope you found this interesting, and we'll see you next time. Cheers. This double-sided tape here is like a foam tape, and it's this 3M VHB, very high bond, and they're not fucking kidding. This stuff is fantastic. If you can get some of this stuff, it's super handy.